All right, team, 16C, that's what we're going to start off today. Now, chapter 16, 16C, 16D helps you understand the general understanding of what derivatives are going to be soon. That's in chapter 17. So this is more of just relating back to what you already know in terms of gradients. So here we go. When they say the term average rate of change, you're going to get very familiar with this term. Okay? Average, we already know. Average, sum of all numbers divided by number of numbers. Rate of change, listening. Listening. Rate of change refers to the change of two variables. In this case, we're going to be looking at the change of y values as compared to x, which this looks very familiar to what you might have learnt in year 9. When did you see y over x? What was that? Gradient. Very good, Jacob. So, gradient is literally your bread and butter, whatever you learnt in year 9, the basics. I'm likely to go back to the basics to teach you how to analyze gradients. I'm literally teaching my year 8 gradients at the moment. Okay, so it goes all the way back to your junior mathematics. You're going to be looking at the relationship between y values as it increases and as x increases. How does that change the problem? That's what we're interested in. So to start off as an introduction, what we have here is a curve. So the red line is the curve. And in summary, when they say average rate of change, what they're interested in is from every single point, from this point to the next point to the next point, what's the change? You see, in a straight line back in year 9, this was nice because if I drew a straight line and I told you this is 1 and that was, let's say, 3, and this is 0, 2, okay, then the next one 2, this is 4, this is 3, and this was 5. So you can see 1, 3, 2, 4, 3, 5. There's a pattern. In a straight line, we call this a linear function. And what's nice about it, the change is consistent. What do I mean by change? Let's have a look. The x-axis values, I went from 1 to 2 to 3. The change that you would have done back in year 8, which is what I'm teaching them right now, if you remember table of values, I'm going from 1 to 2 to 3. What's the change? Moving from 1 to 2 and 2 to 3, what's the change? 1. Plus 1. So this is what my year 8s are following through. So they're learning the patterns of the change. And then I say, well, what about the y values then? So I got the y values, and we look at the y values. I go from 3 to 4 to 5. So you can see here, this is 3, 4, and 5. What is the change moving from 3 to 4, 4 to 5? 1. So when you talk about a gradient back in year 9 or year 8, you look at the change in the sense of what is the change across from 1 to 2 and then 3 to 4. That's why you had y2 minus y1, x2 minus x1. You're looking at 2 points to see the change. And the change clearly is for the y values is plus 1 and for the x values was plus 1. That's why you say there's a gradient of 1. But what that means is that every single point in the linear line, it was also nice that not only this is 1 across, 1 up, the other one is also 1 across, 1 up. And that also means if you picked this point and this point, so 1 to 3 and 3 to 5, it's still a ratio of 1 to 1 because it's 2 over 2. So this is beautiful because in a straight line, it's consistent that the gradient is always a ratio of 1. The problem, which is what we're learning now, is that, well, what happens when you have a curve? See, a straight line is nice and consistent. It's always going to be 1 across, 1 up, 1 across, 1 up, or 2 across, 2 up, 2 across, 2 up. But in a curve, that's not necessarily true. In a curve, it could be 1 across, 1 up, then 2 across, 1 up, and then maybe 1 across, 3 up. The curve changes that rate. So what we're interested in is on the overall average, what is the overall change for the y values, and what's the overall change for the x? So we call that average rate of change. So this curve here, we're picking 2 points. Just like a straight line, we pick 2 points. And when we say average, we just want to know from this point all the way to this point, what was the x change? And then from this point to this point, what was the overall vertical change, which is the y change? Okay, so if I drew the diagram in again, so you can see, this is all you're doing. It sounds crazy, but it's not. All you're really doing is you're looking at what is the x change, so from here to here, what's the change from A to B? And then from A to B, then what is the vertical change? When you put it into definition, it looks scary because this is your rule. So if you look at that rule, you're like, oh man, what does that say? What does that mean? All that is your y2 minus y1 over x2 minus x1. That's all it is. Because that's all you're doing. You're really just doing what's a and b. You're just finding if that was 3 and that was 5, you would find the difference between the two. 5 minus 3 gives you 2. That's all they're doing. 5 minus 3. That's x2 minus x1. How do you find the y values? Well, you'd have to sub that x value into the function. You get a y value. That's why they call it f of a. And they call that f of b. But really, that's just your y2. That's your y1 back in year 9 to find the gradient, which is the change of this rate between what's the x length and what's the y length. That's the gradient between a to b, and we call that the average rate of change. So back in year 9, you were already doing this, okay? But you did it with straight lines. Now we're doing the same thing. We're moving between 2 points, and that's with curves. And we call that the average rate of change, okay? Because obviously it changes over each point, but in a straight line, you didn't have to think about that back in year 9. Okay, so in this exercise, what are they really getting you to do? It's very easy. They're just getting you to find the gradient between 2 points. Literally, that's what you're doing. Okay, so the language is scary. If you look at this entire thing, it looks, oh my God, what is that? Oh my God, what is that? And then interval of A to B, and this is your average rate of change formula. It looks really intense. But if you understand the theory, all it's asking you to do is between 2 points, find the gradient, which means draw a straight line from that point to the next point. What is the y change and what's the x change? That's all it is. So let's do an example. I'm going to do an example over here. So you've got a curve. This is your graph. This is your distance by time. So the y-axis is distance. The x-axis is time. You've got 2 points. They've already got 2 points here. Clearly, 2, in terms of time, they're talking about seconds. So after 2 seconds, you are now 12 meters away from the origin. Then at point 12, so 12 seconds later, you are now 30 meters away from whatever the point is, okay? They want you to find the average speed of the object in meters per second. Now speed, we know is distance over time, which is y over x. If you really think about it, here we go. I'm going to write it down just for those who don't know. Speed is distance over time. But that is the same thing as saying y-axis over x-axis. So they want you to find the average speed from interval t equals 2 to t equals 12. If you have a look at the diagram, they already gave that to you. This is 2, this is 12. Y values already know is 12, and you know this is 30. So all they want you to know or find, and I'm going to change this over here with a ruler, all they want you to find in this question is what is the gradient from those 2 points. Actually, I should do a different color. I'll do it in purple. There you go. That's what it's asking. It wants you to find from this point to this point, what is that gradient right there? Because that gradient is what we call average rate of change. Why? It's in a curve. Every different point changes, but overall, what's the x change? And overall, what's the y change? So if you have to do this, this is back to year 9 mathematics. X-wise, from 2 to 12, how far is that? What's the distance? Horizontally. Yeah, horizontally. What's the distance from here to here? What's the change? 10. Logically. You didn't have to use a formula to figure this one out. It's just clearly 12 take away 2 equals 10, but you knew that. What about vertically? If you're looking at those 2 points, clearly it's 12 to 30, which is 18 units away. So now let's put it together. What's the gradient or the average rate of change? Clearly it is 18 over 10. And you're right, Ollie, it is 1.8, but that's not our answer. What's our answer? Very good, because the question said find the average speed. So you should say average speed.
So do I add units to myself?
1.8 meters per second, sorry?
I add units to myself.
Did you? Most of you did. I'm very happy from the start of the year to now. You should look at the changes that you've done. If you go back to your quadratics and linear, take that sheet and look at where you're at now. There's been a massive change on what you have done. So even though you feel like there hasn't been much change in mathematics, you have. A lot of things that I've talked about, sketching, oh, so beautiful now. It's one nice continuous curve. I'm not seeing hairy graphs anymore. I'm seeing coordinates. I'm seeing question method answer. I'm seeing your solving. I see your layout. Units. There's been a change. And I like that because that means I had an influence on you. It means that over this year, over the last 3 terms, there has been an influence of what I've been telling you what to do. You're doing it. Okay, so that's great. It's good. So I'm really proud of you all. So keep it up. And I'm hoping that I can at least prepare you really well for next year. And then you're on your own from there.
And also, you can help us out.
I can still help around, of course. All right, so this question here, that's all you're doing. So most of these questions you'll find they'll have to tell you the interval. They'll tell you from t equals whatever it is to t equals 12. Same thing for the next problem. They give you an equation instead of a graph this time. You know that this is a quadratic curve. It is not a straight line. And they want you to find the average rate where x is from 1 to 5. Now, if it helps you, you can try to sketch that graph and then picture what it looks like. I don't need to, or I don't think you really need to. You know that it's from 1 to 5. You just need to know what the y values are. Once you know those 2 points, you can then find the gradient. Now, you got the x value of 1, and you got the x value of 5. How do you find the y value? Yeah, that's it. This is the formula here. That just tells you f of, so if I wanted to know when x is 1, f of 1 is 1 squared minus 2 times 1 plus 5. That is 1 minus 2 plus 5. 1 minus 2 is negative 1, so this is 4. So now I know this is 1, 4. Then you find the next one. When x is 5, so f of 5, same thing. 5 squared minus 2 times 5 plus 5. 25 minus 10 plus 5, that's 15, so that's 10. So, now that I've got my 2 points, again, average rate of change, you don't need to draw the graph, but if you understood the idea, all this is asking you to do, yeah.
The answer's 20.
Is it? What did I do? 25 minus 10, 15. Oh, you're right too, thank you. I was testing you.
Good job. Of course. Wow.
I'm glad someone was paying attention.
This time was actually, it was all. It was all.
So it was
I
20.
said this time, actually.
Okay.
Well, actually, this time I was also testing you all too.
Yeah. Oliver is clearly.
Is clearly focused. So, now that we need to find average rate of change, just means to find the gradient between 2 points. So here we go. M is equal to 20 minus 4 over 5 minus 1. I'm just literally doing y2 minus y1, x2 minus x1. And that gives me an answer of 16 on 4. Gives me 4, but that usually, if there is an application, you're meant to then describe what that refers to. Okay, so that will relate to more 16e, but that's what this exercise is about. So it's first introducing finding average rate of change. When you get to derivatives, it's no longer 2 points to find the gradient. You will work with 1 point, and that's what's special about derivatives. Okay, but at the moment, we're trying to work you towards it, so you're going to understand with 2 points, you're doing 16d, 16c, and then 16e, that's where those who do physics, you may be a bit more familiar with velocity and position. Okay? But otherwise, that's what I want you to do for this session. It's 16c to begin with. I don't see you Wednesday, so Friday I'm going to merge the two, 16d and 16e. Very easy topic there. And then we'll start chapter 17 next week. Okay? But that's what I want you to do right now. The questions are up.